All right, today we're going to talk about 10.4, which is talking about inscribed angles and polygons. First off, an inscribed angle is an angle whose vertex is, the important thing here is on the circle, and then whose sides contain chords of the circle. So remembering what a chord is. So if you look at this circle, we have angle B, where its vertex is on the circle, and it is comprised of a chord for each of the sides. And then when it intercepts the circle, it intercepts an arc. It is arc measure AC. And so anytime we want to find the measure of an angle, angle B in this case, so the measure of angle B, and it's right down here, is always going to be equal to half of the measure of its intercepted arc. This is going to be important not only for today, but as we move on with all of the different types of angles. So for number one, of course, it says find the indicated measure, and there are no spaces here. So we're going to find the measure of the following things here. Arc DG, arc DE, arc GF, and then the measure of angle G. So first off, we need to remember that for a circle has 360 degrees total in a circle. And so we have one inscribed angle right here, which is 40 degrees. And it intercepts this arc DG. So that means that 40 has got to be equal to half of its corresponding arc. So that means that arc DG must be 80 degrees. And then we clearly have the center of the circle identified because it has that center point there. So this is circle O, which then also means that we have a diameter here, which cuts the circle in half, so that we know that this arc that's left, since the total circle is 360, EG cuts it in half. We know that there has to be 100 degrees left for arc DE. And then for arc GF, we can take what we have with 100 and then 80 and then 58 and subtract that from 360 and find out what is left for arc GF, which is going to be 122 degrees. And then our last one is angle G, which is an inscribed angle. Its vertex is clearly on the circle, and it is made up of two chords. So this angle in here is equal to half of the arc where it intercepts the circle, which is this arc. So half of 58 would be 29 degrees. Which leads to, when you have two inscribed angles or multiple inscribed angles of the circle, and they are intercepting the same arc. So if we look here in this theorem here, it says that angle D, which is made up of chord AD and chord DB, it clearly intercepts the circle at that arc. So I don't know what angle D is yet, but I do know that angle D is going to be equal to half of arc AB. But then I also have another angle, angle C right here, which is made up of chord AC and chord CB, and it also intercepts that same arc. So I know that the measure of angle C is equal to half of that arc as well. And since I know that they are both equal to half of the same thing, that's where you get the fact that those two angles must be equal to each other. Which leads then to example 2. So in example 2, we have this angle right here is 109 degrees, and its vertex is on the circle. It intercepts this whole arc, which means that that whole arc must be 218 degrees. So that answers the first part. The measure of HML has got to be 218 degrees. And then the measure of the angle HJL, which is right here, is another angle whose vertex is on the circle, and it intercepts the same arc. So it has to be half of 218 or also equal to 109, which is the exact same thing. We can use just one letter if we want to say angle J. And then same concept over here for number 3. We have angle C right there. And we also have angle B, both of which the vertices are on the circle. They both intercept this arc. So the measure of arc AD would have to be twice that, which is 136, and then also makes angle B half of that as well. Or you could just say that they're equal right away because they intercept the same arc. So you get the measure of angle B is 68 degrees. Next thing we're talking about is inscribed polygon. And polygon is said to be an inscribed polygon when all vertices are on the circle. And then you have a circumscribed circle, so it's the circle that is around the polygon, or an inscribed polygon because the polygon is inside the circle. And so you can say it in both directions there. So for this inscribed polygon example, this would be a quad inscribed in a circle. And over here, we could say a triangle circumscribed around a circle. So in the left example here, we have the quad inscribed in a circle. It's where all the vertices are on the circle. And then on the right example, this is where all of these are tangents, remembering that vocab where they only touch the circle at one spot on each side there. So none of these side lengths would ever touch the circle more than once. And then you have some specific things that happen when you have inscribed polygons. So the inscribed right triangle theorem is really just illustrating an inscribed angle, because if you have a right triangle, that means that angle B is the right angle here. That opposite of the right angle, which must be the hypotenuse, must also be the diameter, because if you have a right angle, you must have the fact that the arc is 180 degrees. So the right triangle having the hypotenuse will always be the diameter for an inscribed right triangle. It's only when it's a right triangle, but it's just following the inscribed angle theorem. And then an inscribed quad. A quad can be inscribed in a circle if and only if its opposite angles are supplementary. So we're going to know that angles E and G add up to 180 degrees. And we're also going to know that angles F and D are going to add up to 180 degrees. So remembering these two theorems and how we apply them will be extremely helpful as we move forward. So for number 4, in A, we have clearly the center marked. Clearly that has to be the diameter, which means we have 180 degrees for this arc, which means inscribed to 180 degrees is this angle. So 5x must be equal to 90 degrees. For B, it's the quad. So we need to take our opposite angles and say that they are supplementary. So we have 3A and 111. So we're going to say that they add up to 180 degrees. So I'm going to get A as a value of 23. And then separately, I have 65 and B. They must also be supplementary. So B has to equal 115 degrees. Number 5 has some overlapping arcs that we have to pay attention to here. First off, we have arc ADC. So remember, that means you have to start at A, go through D, and then over to C. So this arc is 134 degrees. That arc is intercepting with this chord and this chord, which means I can now find the measure of angle B, because angle B is an inscribed angle. So the measure of angle B has got to be 134 divided by 2. It's always half of the arc, which means that angle B is 67 degrees. Because I have angle B, I'm able to find angle D, now knowing the fact that opposite angles are supplementary. So if I subtract 67 from 180 degrees, I will get 113. And then separately deal with angles A and C. If angle A is 104 degrees, then its opposite angle over here, angle C, must be supplementary to angle C. So I can get the measure of angle C is 76 degrees. Number 6 is a little bit of review. We have a regular polygon. The pentagon is inscribed, so we have all 5 vertices are on the circle. But the fact that it is regular is really important, because that means that all 5 of these sides are congruent. And we talked in a previous section that if you have congruent chords, then that means that the corresponding arcs must also be congruent. So the measure of all of those arcs are congruent, which means I have 5 equal arcs in a circle that must total 360 degrees. So if I take my 360 and divide it by 5, I find out that each arc must equal 72 degrees. Now I can go in and find PQ as just one of them. So the measure of arc PQ is 72 degrees. And then the measure of arc RST, so starting at R through S to T, is 2 of those 72s. So the measure of arc RST is 144 degrees. And then lastly is a review of a system. Again, remembering that a quad is inscribed in a circle, which means that the opposite angles must be supplementary. So those 2 angles must be supplementary. And then these opposite angles must be supplementary. And then we are reviewing how to solve a system. I would encourage you to pause it and see if you can finish solving this system on your own, which we will need to know how to do. I am going to choose to eliminate my x's. So I get a y value of 5. Plug in my y value of 5 into either one of those equations. And I get x is 25 and y is 5. So remembering a couple things here, a couple big things in here. Inscribed angle must be a vertex on the circle, and then 2 chords making it up, and it's also always equal to half of its corresponding arc. And then if you have 2 angles that are inscribed to the same arc, they obviously must be congruent because they're going to be equal to half of the same thing. And then talking about polygons that are inside